So today we will start with new topic, atomic physics. This is advanced topic, that is group C. Then and we will discuss Bohr, Sommerfeld theory of hydrogen atom. Then we will learn the postulates which Bohr proposed for Bohr atomic model. Firstly, that is in an atom, electron revolve in circular orbits around the nucleus. This is nucleus, and electron revolve around the circular orbits under the influence of Coulomb attraction between the nucleus, that is in nucleus we have proton which is positively charged and electron which is negatively charged. So the Coulomb attraction between the nucleus and the electron. Secondly, electron revolve only in those circular orbits where the magnitude of angular momentum, this is angular momentum, magnitude of angular momentum. We said magnitude, so we will skip the direction part. Magnitude of angular momentum is some integral multiple of h by 2 pi. Integral multiple, so n. Here n runs from 1, 2, 3 dot dot dot. Thirdly, electron makes a transition from one orbit of total energy EI to another orbit of total energy EF. Then absorption or emission takes place in the form of electromagnetic radiation. Electromagnetic radiation. When an electron makes a transition from one orbit of total energy EI to another orbit of total energy EF, then the emission of or absorption takes place in the form of electromagnetic radiation. The energy of the emitted or absorbed photon, energy of this will be equal to EI difference of EF. Okay. For emission, we have EI greater than EF. Then from here we can calculate mu. Frequency of radiation is given by EI minus EF by H. So through a diagram we can depict it as some orbit of Ni Nf with energy EI and say EF. So electromagnetic radiation with energy H nu. And this Bohr atomic model is applicable only to one electron atoms. Now we will explain the spectra of hydrogen like atom. So let the charge of nucleus be Z times electronic charge, charge of electron be minus C, and mass of electron be ME, mass of electron. Now according to Bohr's theory, electron revolve in circular orbit around the nucleus. The required centripetal force is provided by Coulomb attraction between the nucleus and the electron. So mathematically we can write the centripetal force, that is mv square by Rn, velocity of the electron and radius of the nucleus, 1 by 4 pi epsilon 0, or say epsilon naught, times the charge of the nucleus times charge of the electron by Rn square. So centripetal force provided by Coulombic attraction. So from here, if we calculate, we will have both side we can multiply by m r n square, then we will have both side multiplied by m rn square. So m square rn square vn square by rn 1 by 4 pi epsilon naught z e square by rn square, both side multiplied by m rn square. So solving further, we can have, previously we have quoted that m v r is equal to nh by 2 pi. So using that, here we will have nh by 2 pi whole square to 1 by rn is equal to this, and this will cancel out. So m z e square by 4 pi epsilon naught. From here we will have radius of our orbital n square h square epsilon naught by pi m z e square, where n runs from 1 2 3 dot dot dot. Depending on the n, it is directly proportional to n square. For each orbit we can have radius of the orbital. For n is equal to 1 2 3 and so on. For example, hydrogen atom z is equal to 1 for the first orbital, r1 will be equal to, we have the formula Rn is equal to n square h square epsilon naught by pi m z e square. So R1 is equal to 1 whole square into h square epsilon naught by pi m z1 e square. So putting the values, h is Planck's constant 6.6 into 10 to the minus 34 whole square, epsilon naught 8.85 into 10 to the minus 12 by 3.14 pi mass of the electron 9.1 into 10 to the minus 31, charge of the electron 1.6 into 10 to the minus 19 whole square. So calculating, we will get 5.27 into 10 to the minus 11 meter. So R1 is equal to 0.527 Armstrong, which is nearly equal to 0.53 Armstrong, and this we called as Bohr radius, denoted as A0, which we will use further. So till now we will learn the formula of Rn. This we must keep in our mind, and we must know the Bohr radius value, that is A0 0.53 Armstrong. What is the benefit of remembering this? If we know R1 for n is equal to 2, that is R2, we can simply do, as we have calculated the value of n pi square h epsilon naught pi m z e square, z is equal to 1 for hydrogen atom. So this is constant, which is 0.53. So n, for n is equal to 2, we will have 4 into 0.53 Armstrong, that is equal to 2.12 Armstrong. Similarly, you can calculate for n equal to 3 and so on, as R3, which is equal to 9 into 0.53 Armstrong, and so on. Now we know that mvr is equal to nh by 2 pi, as we have denoted previously as rn and vn, so we will denote it over here also. And we have known the value of rn, so here we have vn is equal to nh by 2 pi m rn. Now we will write nh by 2 pi m, and rn we have n square pi square n square h square, sorry, epsilon naught by pi m z e square. So we have vn is equal to z, mm cancel out, pi cancels out, h remains, so we will have z e square by 2 n h epsilon naught, where n is equal to 1 to. So we have calculated the velocity. Now total energy of the hydrogen like atom, which is equal to En. As we know, total energy is equal to kinetic energy plus potential energy, which is half mv square, mv square plus the charge of the nucleus multiplied by the charge of the electron, m q1 q2 by 4 pi 1 by 4 pi epsilon 0 into r, that is equal to q1 q2 by 4 pi epsilon naught to r n, potential energy equal to, therefore n square h square epsilon naught by pi m z e square. Calculating, we will have m z square e to the power 4 pi 8 n square h square epsilon naught square minus m z square e to the power 4 by 4 n square h square epsilon naught square, which is equal to minus m e to the power 4 z square by 8 epsilon naught square n square h square, which is equal to minus m e to the power 4 by 8 epsilon naught square h cube c into z square hc by n square, where we can denote En is equal to minus r z square hc by n square, where r is equal to m e to the power 4 by 8 epsilon naught h cube c. This is known as the Rydberg constant. So r is known as the Rydberg constant. Calculating the Rydberg constant, we will have m e to the power 4 pi 8 epsilon naught square c h cube, which is equal to, we'll put the values now of the constants. Mass as 9.1 into 10 to the minus 31, charge as 1.6 into 10 to the minus 19 whole to the power 4 by 8 into 8.85 into 10 to the minus 12 whole square, the speed 3 into 10 to the 8 into Planck constant 6.6 into 10 to the power minus 34 whole cube. Calculating, we will have value is 1.0974 into 10 to the power 7. This is the value of Rydberg constant. And for hydrogen, as z is equal to 1, we will have En is equal to minus r hc by n square. So we have learned the value of Rydberg constant, total energy form equation, velocity equation, and radius equation. If we calculate En value, placing the value of r, we will have minus 13.6 by n square electron volt. Therefore, for n is equal to 1, E1 is equal to minus 13.6 electron volt, n is equal to 2, E2 is equal to minus 3.4 electron volt, n is equal to 3, we have E3 is equal to minus 1.51 electron volt, and if we continue, we will have, for n is equal to infinity, energy will be 0 electron volt. So if we write the energy spacings increases, that is for n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, dot dot dot, n is equal to infinity. 0 electron volt, here we have minus 0.85 electron volt, minus 1.51 electron volt, minus 3.4 electron volt, minus 13.6 electron volt, and so on. And the minimum energy required to remove electron completely from the orbit is called binding energy. So binding energy of hydrogen 13.6 electron volt. Sometimes energy is expressed in term value. So denoted by capital T, we will have E by Hc. This is equal to nu bar, when nu bar is known as wave number. Unit of nu bar will be equal to meter inverse or centimeter inverse. Great. So mu bar for nth state will be is equal to minus 13.6 by n square Hc z square m inverse. That is E value we have placed over here, that is minus 13.6 by n square by Hc to z square meter inverse or say centimeter inverse. We have, if we have two body problem and we want to convert it into one body problem, we will have to introduce the concept of reduced mass denoted by mu. Therefore mass, reduced mass will be equal to mass of the nucleus, mass of the electron by m nucleus plus m electron, where m nucleus tends to infinity. If, then mu is equal to m electron. We have to remember one more thing, that is the ratio of mass of proton to mass of electron is equal to 1836. 1836. For hydrogen, if we calculate it, then 1836 Me times Me by 1837 Me is equal to 1836 by 1837 energy Now we will discuss positronium atom. You must be wondering what is positronium atom. It is the bound state of electron and a positron. What is positron? It is an antiparticle of electron. So in positronium, nucleus will contain one positron with charge plus E and the electron charge minus E. So now if we calculate the reduced mass for positronium atom, we will have the nucleus mass of the nucleus, which is Me. The mass remains the same for both, so Me, and the mass of the electron Me by Me plus Me twice Me, which is equal to Me by 2. So reduced mass will be Me by 2. Now if we say calculate energy of positronium atom of nth state, then En will be equal to minus 13.6 by n square, and in place of Me we have put Me by 2, so twice n square electron volt. And the speed of the electron, if we calculate, that is the speed of the positronium, as we know Vn is equal to Ze square by twice n H epsilon naught. Here we can see that it does not depend on the mass, or say here we will say reduced mass. So velocity of the positronium will be same as that of the hydrogen atom. Velocity same, mass will be equal to Me by 2, that is half of the mass of the electron, and energy will be also half of that of hydrogen atom, therefore half of E hydrogen. And if we see radius of positronium, that is R, we know that Rn is equal to m e to the power 4 by 8 pi epsilon naught square h cube c. Here we see that it depends on the mass, that is directly proportional to mass, so R positronium will also be equal to half of that of radius of hydrogen atom. Velocity remains unchanged, radius is half of that of hydrogen atom, energy is also half of that of hydrogen atom, reduced mass, that is mass of the positronium, is half of that of mass of the electron. Now we will study muonic atom. Here we will see mass of muon, that is mu, is 207 times of mass of electron. So it is hydrogen like atom in which electron is replaced by a muon. So reduced mass of muonic atom will be equal to mass of the nucleus, mass of the, we will have nucleus with a proton, and here the electron is replaced by muon. So mass will be equal to 207 times of mass of the electrons. So nuclear mass and the revolving atom mass by mp plus mu, we will have, as we have seen before, mass of the proton is 1836 times of the mass of the electron, and from here we can see mass of the muon is equal to 207 times of mass of electron. So 1836 plus 207 of Ma, solving we will get 186 Ma. So muonic mass, that is reduced mass, is 186 times of the mass of the electron. So binding energy, if we calculate, will be equal to 13.6 into 186 electron volt is equal to 2529 electron volt. time period and frequency of revolution in hydrogen like atom. So frequency, what we call, define it as number of revolutions in unit second. Time period of revolution Tn is equal to 2 pi Rn by Vn. As we know, velocity is equal to distance traveled by time taken. 2 pi Rn is equal to the perimeter, so that is the distance. So from here we will have, as we know, Vn is equal to Z E square by 2 epsilon naught n h, and Rn is equal to n square h square epsilon naught by pi mz e square. So Tn is equal to 2 pi n square h square epsilon naught by pi mz e square, that is the r value 2 pi Rn into 1 by Vn. So 2 epsilon naught nh by z e square, which implies Tn is equal to 4 epsilon naught n cube h cube by mz square e to the power 4. So time period is this, and frequency of revolution will be is equal to 1 by Tn, therefore is equal to mz square e to the power 4 by 4 epsilon naught n cube h cube. These are the important terms we must remember. So we will solve one problem related to the theory which we have studied. So the question goes as, if protons were 10 times lighter, then the ground state energy of the electron in a hydrogen atom would be less, more, same, or less, more, or equal depending on the electron mass. So we have to calculate the ground state energy of the hydrogen atom given the protons were 10 times lighter. So let's begin. The energy of electron in nth state orbit in hydrogen atom, that is En, is given as minus mu z square e to the power 4 by 8 epsilon naught square h square 1 by n square. So mu will be equal to reduced mass, that is equal to mass of the electron into the mass of the proton by mass of electron plus mass of proton. As we have said, mass of the proton will be 10 times less. Let us denote this as mp dashed, and we know the mass of the proton is 1836 times of the mass of the electrons. So me into 1836 me by 10 into me plus 1836 me by 10. So we will have 1836 me square into 10 by 10 into 1846 me, which implies 1836 me square by 1846 me. Me cancels, 1836 me by 1846. Therefore we have the reduced mass to that of me equal to 1836 by 1846, which is equal to 0.9946. For normal proton we have mp, the ground state energy is minus 13.6 electron volt. Now for mp dashed we will have ground state energy as minus 13.6 into 0.9946, which is equal to minus 13.526 electron volt. Clearly we can see that here the ground state energy is more. So we will arrive to the conclusion that ground state energy will be more. So it will be more. So what we have done, we have written, we only have to calculate the reduced mass, and the reduced mass means for calculating two body problem in one body problem terms. Here mass of the proton is 10 times lighter than the mass of the proton, which we take as 1836 times the mass of the electron. So only we have calculated the reduced mass, and then this is the reduced mass, and from here we can have the ground state energy for both the cases, and we can derive come to the conclusion if the ground state energy is more or less. So that's all for today. Thank you.